Good morning. I am Dr.Bindhu, Assistant Professor, Department of Mathematics, Emmanuel Arasa JJ College of Engineering. My topic: Euclidean n-space or power n and dot cross products. Condense vectors in R power n, length of a vector, dot product, cross product. Vectors in R power n, an ordered n tuple, a sequence of n real numbers h1, h2, etc. hn, taken n real number values are given there. Then n space means R power n. Thus R power n set all the elements in this n tuple form elements belongs to R power n. Example: take n equal to 1, then R power 1, 1 space, the set of all real numbers. Next, take n equal to 2, R square, it is called 2 space set, the set of all ordered pair of real numbers. Take 2 real numbers h1, h2. Next, take n equal to 3, R cube, then it is called the 3 space set, the set of all ordered triple of real numbers. Then take 3 real numbers h1, h2, h3. Next, take n equal to 4, then set is R power 4, it is called the 4 space set, the set of all ordered quadruple of real numbers. Then take 4 real numbers h1, h2, h3, h4. Then other form of quadruple of real numbers is h5, h6, h7, h8. Notes. Then first one is an n tuple. Take n real numbers h1, h2, etc. hn can be viewed as a point in R power n with the xi as its coordinates. The next one is a vector and n tuple h1, h2, etc. hn can be viewed as a vector. Then x equal to h1, h2, etc. hn in R power n with the xi as its components. Then example of, then first figure is a point examples, then second one is a vector examples. Take two vectors u equal to u1, u2, etc. un and v equal to v1, v2, etc. vn. Then two vectors in R power n. Then first condition equal. Then two vectors are equal, u equal to v if and only if. Then first element is equal, u1 equal to v1. Then second element is equal, u2 equal to v2. Then etc. Then last element is equal, un equal to vn. That is called two vectors are equal, u equal to v. The next one is vector addition. Then two vectors added here, u plus v equal to, the first element is added there, u1 plus v1, the second is u2 plus v2, then etc. Last one is un plus vn. Next one, scalar multiplication. Cu equal to Cu1, Cu2, etc. Cun. C is a scalar element. Note, the sum of two vectors and the scalar multiple of a vector in R power n, it is called the standard operations in R power n. Negative minus u, then minus is multiplied in the one vector, minus u equal to, then multiply the all the elements inside the all the elements, minus u1, minus u2, etc. minus un. Difference, then two vectors difference, u minus v equal to, subtract the first element and the second element, then etc. n elements, u1 minus v1, u2 minus v2, etc. un minus vn. Next is zero vector. Zero vector equal to all the elements are 0, 0, 0, etc. 0. Notes, the zero vector is called the additive identity in R power n and the vector minus v is called the additive inverse of v. Next, the properties of vector addition and scalar multiplication. Let it take three vectors in R power n, u, v and w. Then C be a scalar element. Then first property is u plus v is a vector in R power n. then two vectors are r power n, u and v, then adding the two vectors u plus v, then answer is a vector that is belongs to r power n. The next one is a commutative property, u plus v equal to v plus u. Then third one is a associative property, then u plus v plus w equal to u plus v plus w. Left hand side first two vectors is added there, then next then add the w vector, then right hand side first last two vectors is added there, then next then add the u vector. Then fourth property, u plus 0 equal to u. 0 is the additive identity vector. Then fifth property is u plus minus u equal to 0. Then sixth property is cu is a vector, it belongs to r power n. Then next one is c into u plus v equal to cu plus cv. Then eighth property, c plus d into u vector equal to cu plus du. The ninth property, c into du equal to cd into u, and tenth property is 1 into u equal to u. Then on example, vector operations in r power 4. r power 4 means taking 4 elements in this vector. Let u equal to, then 4 elements, 2, minus 1, 5, 0. b equal to 4, 3, 1, minus 1. And w equal to minus 6, 2, 0, 3. Be vectors in r power 4. Then solve the x value. Then first part, x equal to 2u minus v plus w. That is equal to 2u minus v minus 3w. This minus is multiplying the inside the box. Then first, then to substitute the values, 2 into u vector, then 2 is multiplying the u vector, then first element is 4, second element is minus 2, then 5, 10, comma 0, then minus v element is right there, then minus of 3w, then 3 is multiplying the w vector, minus 6 into 3, 18, minus then 2 into 3, 6, then 0 into 3, 0, then 3 into 3, 9. Then subtract the elements, then first element 4, minus 4, plus 18, then second element minus 2, minus 3, minus 6, then third element is 10, minus 1, minus 0, then last element is 0, plus 1, minus 9. Then answer is 18, minus 11, 9, minus 8. P part, 3 into x plus w equal to 2u minus p plus x. Then multiplying the 3x plus 3w equal to 2u minus p plus x. Then x is take the left hand side, plus x is given there, take the left side, then sign is changed, minus x, that is equal to 2u minus p, then 3w is a sign is plus, then take the right hand side, change the sign, minus 3w, then 3x minus x is 2x equal to 2u minus v minus w. Then x equal to, then 2 is take the right side, then 2 is multiplying there, then take the outside, this divided there, 1 by 2 is given there, then 1 by 2 is multiplying the all the three values, then first element is 2u divided by 2, then 2 is cancelled, u minus, then next element 1 by 2 into v minus other one 3 by 2 into w, then u value, u vector value is right there, plus minus 1 by 2 into v, then multiplying 1 by 2 in the v vector, plus then third element 3 by 2, 3 by 2 is multiplying in w vector. Then final answer is 9 minus 11 by 2, 9 by 2 minus 4. Let V be a vector in R power n and C be a scalar, then the following is true. The first one, the additive identity is unique. That is, if u plus v equal to v, then u equal to 0. The additive inverse of v is unique. That is, if v plus u equal to 0, then u equal to minus v. See, third one, 0 v equal to 0. Fourth one, c into 0 equal to 0. Next one, if cv equal to 0, then c equal to 0 or b equal to 0. Then last one is minus of minus v equal to v. Minus into minus is plus, then that is equal to v. Linear combination. The vector x is called a linear combination of v1, v2, etc. vn. If it can be expressed in the form, then its vector equal to c1 v1 plus c2 v2 plus etc. cn vn. c1, c2, etc. cn is called the scalar elements. Then its vector is a linear combination of v1, v2, etc. bn. Then other example given, x equal to minus 1, minus 2, minus 2, u equal to 0, 1, 4, b equal to minus 1, 1, 2, and w equal to 3, 1, 2 in R cube set. Find a, b, c such that x equal to au plus bb plus cw. Solution. Then equation is x equal to au plus bb plus cw. This all the values are substituted in this equation. Then first x vector value is given there. X first element is minus 1. Then minus 1 equal to, then minus 1 write the right hand side there equal to. Then first is u vector first element is 0. 0 into u equal to 0 into a equal to a 0. Then first term is 0. Then next v vector first element is minus 1. Minus 1 into b minus b. Plus w vector first element is 3. 3 into c equal to minus 1. Then first equation. Then second equation. And then x vector second element is minus 2. Write the right hand side here equal to. Then u vector second element is 1. 1 into a plus b vector second element is 1. 1 into b plus w vector second element is 1. 1 into c equal to minus 2. Then last the x vector third element is minus 2 equal to. Then u vector third element is 4. 4a plus b vector the third element 2. 2b plus w vector last element is 2. 2c equal to minus 2. These three equations are solved that. Then final answer is a equal to 1, b equal to minus 2, c equal to minus 1. These three values are substitute the equation x equal to au plus bv plus cw. Then equation is x equal to u minus 2v minus w. Note, a vector u equal to u1, u2, etc. un in R power n can be 1 by n row matrix. Row matrix are row vector. Then u equal to u1, u2, etc. un, right? Only one row is called the row vector. The next one is n by 1 column matrix or column vector. Then u equal to u1, u2, etc. un. Then only one column is given there. It is called the column vector or column matrix. Then matrix vector addition and scalar multiplication. Then u and v vectors adding there. U plus v equal to u1 plus v1, u2 plus v2, etc. un plus vn. Then cu equal to c into u1, u2, etc. un. The c is multiplying inside that cu u1, cu2, etc. cun. Then adding the matrix element u plus v equal to, then u matrix term u1, u2, etc. un, v matrix term v1, v2, etc. vn. Then adding that answer is matrix of u1 plus v1, u2 plus v2, etc. un plus vn. Then scalar multiplication cu equal to c into u matrix, write the u matrix u1, u2, etc. un. Then multiplying there c cu1, cu2, etc. cun. Then it is a only one row is given there. It is called row matrix. Then U plus V is a column matrix is ordered there. Then first U column matrix, U vector column matrix, U1, U2, etc. Un plus next V1, V2, etc. Vn. Then adding the two matrix set, answer is U1 plus V1, U2 plus V2, etc. Un plus Vn. This is called the column matrix. Then scalar multiplication matrix Cu equal to C into, write the U column matrix U1, U2, etc. Un, that is equal to Cu1, Cu2, etc. Cun. Length and dot product in R power n. Length of a vector V equal to V1, V2, etc. Vn, its element belongs to R power n. Now B definition is equal to root of V1 square plus V2 square plus etc. plus Vn square. Then now B is called the length of a vector. Then length of a vector is also called its norm. Other length of a vector is, other name is a norm. Properties of length: norm V greater than or equal to 0. Next one is norm V equal to 1. V is called a unit vector. Norm V equal to 0 if and only if V equal to 0. Norm CV equal to modulus C into norm B. C is a scalar element, then take the modulus. Example 1. In R power 5, R power 5 means then elements belongs to take in 5 elements in one vector. The length of V equal to 0, minus 2, 1, 4, minus 2. Then find the value of length value. Then first find the norm V. Norm V is called the length value. Norm V equal to root of first element is square plus second element minus 2 the whole square plus 1 square plus 4 square plus minus 2 the whole square. Root of, then adding the square, the first square the all the elements and all the elements are adding that, answer is 25. Then root 25 equal to 5. Next example is in R cube set, then take in 3 elements in one vector. Then V equal to root 2 by root 17 minus 2 by root 17, 3 by root 17. And then find the norm B value, root of 2 by root 17 the whole square plus minus 2 by root 17 the whole square plus 3 by root 17 the whole square equal to this square, first square the all the elements, then adding that, then root of 17 by 17. The answer is 1. Then one norm B equal to 1, and then V is a unit vector. A standard unit vector in R power n. Then unit vector is denote the letter E1, E2, E2, etc. En. E1 unit vector is 1, 0, etc. 0. E2 unit vector is 0, 1, etc. 0. Then etc. En unit vector in 0, 0, 1. Then some example, the standard unit vector in R square. R square set to the element form is a ordered pair elements that take in 2 elements I and j. I element form is 1, 0. J element is a 0, 1. It is called the standard unit vector. Unit means 1. Thus one element is 1 is given. The standard unit vector in R cube, then take in 3 elements I, j, k. Then I element form is 1, 0, 0. J element form is 0, 1, 0. And k element form is 0, 0, 1. Two non-zero vectors are parallel. Parallel condition U equal to CV. U vector equal to scalar multiplication vector CV. C scalar element is greater than 0. Then positive value U and V have the same direction. Then C less than 0. Then U and V vectors have the opposite direction. Length of a scalar multiple. Let V be a vector in R power n and C be a scalar. Then norm CV equal to modulus C into modulus V. Then proof. Then take in V vector V1, V2, etc. Vn. Then write the CV equal to, then multiplying the C scalar element in the vector set. CV1, CV2, etc. CVN. Next find the values of norm CV equal to norm definition is root of first element square plus CV1 square plus CV2 square plus etc. CVN square. Then C square is a common value, then take the outside, then C square into, write the remaining values V1 square plus V2 square plus etc. Vn square. Then root C square value is a C, then take the outside, then write the modulus C. C is a scalar elements, then addition and plus and minus are given there, then take the modulus value modulus C, then root of remaining values V1 square plus V2 square plus etc. Vn square, then modulus C into this root value is C, norm V value, this norm CV equal to modulus C into norm B. If V is a non-zero vector in R power n, then the vector U equal to V divided by norm B has length 1 and has the same direction as V. This vector U is called the unit vector in the direction of B. Then proof: V is a non-zero vector in R power n, that is norm B not equal to 0, then implies 1 by norm B is a greater than 0. Norm B is not equal to 0 means then is a norm is a only positive value, then not equal to 0, this 0 is not there, then 1 divided by norm B is a greater than 0. Then U equal to 1 by norm B into V. U has the same direction, so U value is 1 by norm B into V. Then norm U equal to norm of V by norm B. Then norm B divided by norm B. Norm B is a cancelled, that is equal to 1. Thus norm U equal to 1. Then U has a unit length. The notes: the vector V by norm B is called the unit vector in the direction of V. The process of finding the unit vector in the direction of V is called normalizing the vector D. Finding unit vector: find the unit vector in the direction V, value 3, minus 1, 2, and verify that this vector has length 1. Then first find the unit vector. Unit vector definition norm B equal to 1. Then first find the value of norm B equal to root of 3 square plus minus 1 square plus 2 square. Then answer is root 14. Then find the value B by norm B. B value is 3 minus 1 2 and norm B is a root 14, that is 3 minus 1 2 divided by root 14 equal to 3 by root 14 minus 1 by root 14 2 by root 14. Next find the root value. Root of 3 root 14 the whole square plus minus 1 by root 14 the whole square plus 2 by root 14 the whole square. Then first squaring all the elements, then adding that, then answer is root 14 by 14 equal to 1. Then B by norm B is a unit vector. Then distance of two vectors. The distance between two vectors U and V in R power n, then D of U comma B. D means distance. D of U comma V equal to norm of U minus V. Then properties of distance. Distance of U comma V greater than or equal to 0, then only positive value, distance value. Then D of U comma V equal to 0 if and only if U equal to 0, then D of U comma V equal to D of V comma U. Then one example is given there, distance between two vectors. Then take the two vectors are given there, U and V. Then find the value of du comma V equal to, then definition norm of U minus V, norm of, then subtract the two vectors 0 minus 2, 2 minus 0, 2 minus 1. Then that is equal to, then norm definition is root of minus 2 square plus 2 square plus 1 square. Then answer is 3. The distance of two vectors is 3. Dot product. Then dot product is first two vectors u and v, u equal to u1, u2, etc. un, and v equal to v1, v2, etc. vn. Then dot product u dot p equal to, then multiplying the two vectors, u first vectors, first elements is multiplying there u1 into v1 plus second vector element u2 into v2 plus etc. last element un into dn. One example, the dot product u and v vectors are given there, then find the dot product value u dot v equal to, first multiplying the first element 1 into 3 plus next second element 2 into minus 2 plus third element 0 into 4 plus fourth element minus 3 into 2, then first 3 plus minus 4 plus 0 minus 6, then answer is minus 7. Then properties of dot product, u, v and w are three vectors in R power n. C is a scalar, then the following vectors are true. Then u dot v equal to v dot u, then commutative property in multiplication. The next one is a distributive property, u dot p plus w equal to u dot p plus u dot w. Next is c into u dot v equal to cu dot v equal to u dot cv. Then fourth property, v dot v equal to norm v square. Then last one is v dot v greater than or equal to 0. Then v dot v equal to 0. Then if and only if v equal to v vector is 0. Find the dot product value u, v, w. Take the three vectors u 2, minus 2, v 5, 8, w minus 4, 3. Then first find the value of u dot v. U dot v to first 2 into 5 plus minus 2 into 8 equal to minus 6. Next will be part u dot v into w equal to minus 6. U dot value is minus 6, then w vector is minus 4, 3, then multiplying the minus 6 inside the box, then minus 6 into minus 4, 24, then minus 6 into 3, minus 18. Then the C part, u dot 2v, then 2 is a, take the outside, 2 into u dot v, u dot value is a minus 6, then answer is 12. Minus 12. Then D part, norm w square. Norm w square is definition w dot w. Then w vector is then multiplying there. Then answer is 25. Then v minus 2w. V and w vectors are substitute there. Then answer is 13, 2. Then properties of the dot product, given u dot u equal to 39, u dot v equal to minus 3, then v dot v equal to 79. Find u plus 2v dot 3u plus v. Then u plus 2v dot 3u plus v, first the multiplying there, then u dot, then first element value is u dot, then other element 3u plus v, plus second element 2v dot, then 3u plus v. Then next u dot first element 3u plus u dot second element v, 3v plus 2v dot first element 2v dot 3u plus 2v dot v. Then 3 is a scalar element, then take the outside, then 3 into u dot u plus u dot v plus 2 and 3 are scalar elements, then take the outside, 2 into 3 are 6, 6 into v dot u plus 2 into v dot v. Then 3 into u dot v, then u dot v elements, this 1, 6, 7 u dot v plus 2 v dot v. Then u dot u value is 39, u dot v value is minus 3 and v dot v value is 79. This multiplying the elements, then adding that all the elements, then the final answer is 254. theorem, Cauchy-Scott's inequality. If u and v vectors in R power n, then modulus u dot v less than or equal to norm u into norm v. It is called the Cauchy-Scott's inequality. The example of Cauchy-Scott's inequality, then take two vectors u and v, then verify the Cauchy-Scott's inequality. First find the values of u dot v, u dot u and v dot p. Then u dot v value is -1, u dot u value is 11, v dot v value is 5. Then next find the value modulus u dot b equal to modulus -1 equal to 1. Next find the value norm u into norm b, that is equal to norm u is root of u dot u, norm v is root of v dot p. Then substitute the values, then answer is root 55. Then Cauchy-Scott's inequality is modulus u dot v. Modulus u dot v answer is 1, and this norm u, norm v value is a root 15. Then sin is less than or equal to, the Cauchy-Scott's inequality is verified. Then angle between two vectors, formula cos theta equal to u dot v divided by norm u into norm v. Then theta values is 0 to pi. One example, find the angle between two vectors. Then take two vectors u and v are given there. Then cos theta formula is u dot v divided by norm u norm v. First find the value of norm u. Norm u definition, root of u dot v, then root of -4 the whole square plus 0 square plus 2 square plus -2 the whole square. Then answer is root 24. Then norm v equal to root of v dot v equal to root of 2 square plus 0 square plus -1 square plus 1 square equal to root 6. Then next find the value of u dot v. Then u dot v value is a -12. Then write the formula cos theta equal to u dot v by norm u norm v. U dot v value is -12, norm u value is a root 24, and norm v value is a root 6. Then values are cancelled there. Then final answer is -1. Orthogonal vectors. Two vectors u and v in R power n are orthogonal if u dot v equal to 0. Then dot value is 0. Then two vectors are orthogonal. Note, the vector 0 is said to be orthogonal to every vector. So some vector is dot to other vector, then answer is 0. Then the 0 is orthogonal to every vector. Determine all vectors in R power n that are orthogonal to u. U value is 4, 2. Then first, then u value is given there. Next take in other one vector v. Then v equal to v1, v2. Then first find the dot product value u dot v equal to u value is 4, 2. Then v value, v vector is v1, v2. Then dot is 4 into v1 plus 2 into v2. Then the value, then 4, 2, 0, then 1, 1 by 2, 0. Then v1 value is minus t by 2. Then v2 equal to t. Then v equal to minus t by 2, t. Then triangle inequality. If u and v are two vectors in R power n, then norm u plus v less than or equal to norm u plus norm v. Then proof, norm u plus v the whole square equal to u plus v dot u plus v. Then u plus v value is write in 2 times u plus v dot u plus v. Then multiplying there u dot u plus v plus v dot u plus v. Then u dot u plus u dot v plus v dot u plus v dot v. Then v dot u equal to u dot v. Already definition there. Then apply this condition. Then u dot u plus u dot v plus u dot v, the plus 2 u dot v plus v dot v. Then u dot u equal to norm u square plus v dot v is norm v square. Then norm u square plus 2 u dot v plus norm v square. Then this value is a, then u dot v is a less than or equal to modulus u dot v. Then apply that equal to is changed there, less than or equal to, the less than or equal to norm u square plus 2 into modulus u dot v plus norm v square. Then modulus u dot v is a less than or equal to norm u into norm v. Then substitute there. Then answer is norm u plus norm v the whole square. Therefore norm u plus v less than or equal to norm u plus norm v. Pythagorean theorem. If u and v vectors in R power n, then u and v are orthogonal if and only if Pythagorean condition norm u plus v the whole square equal to norm u square plus norm v square. Dot product and matrix multiplication. Then u matrix is a column matrix u1 u2 etc. un. V vector is a column vector v1 v2 etc. vn. Then u dot v equal to, u dot v is a matrix formula is u transpose into v. Then u transpose is a column vector is changed to row matrix. Then u1 u2 etc. un. Then write the b matrix v1 v2 etc. vn. Then multiplying there two matrix, then matrix of u1 v1 plus u2 v2 plus etc. plus un vn. Then cross product. Then u vector u1 u2 u3 and v vector v1 v2 v3. Then w equal to u cross v. Then cross product formula is I vector j vector k vector equal to u1 u2 u3 in u3 v1 v2 v3. That is equal to u2 v3 minus u3 v2 comma u3 v. Thank you.